wanna learn, put your mind to.
Today is a new day. Forget the past and focus on today. Okay, boom, we're about to get started today. What are we doing? The last chapter in probability, right? The last chapter in probability. What is that? The fundamental counting principle. That's something new that you haven't done before. So what is the fundamental counting principle? It's just basically looking at how many options are available. So how many possible options are there, right? So example, how many possible options are there to arrange a word, right? How many ways can you arrange the word gang, right? So how do you do that? Okay, or another word, how many options, like for example, let's say you have 3 dresses and 12 heels. How many possible outfits can you make out of those, right? How would you do that? You would say 12 times 3, right? Because you're saying 12 number of heels times 3 number of shoes will result in the number of possible options that I can have for number of outfits that I can wear. Those are numbers without including how many you don't like or whatever, what doesn't match nicely. But anyway, so those are the number of available options, right? So it'll be 12 times 3, which will give you 36 options or choices of outfits, right? So that's basically what fundamental of counting principle is all about. So there's factorial notation under fundamental principles because there are numbers that are too high for you to work with using 12 times 3 or something like that. So that's where we introduce the factorial sign. What is the factorial sign? It's that little sign on your calculator that is a little exclamation point, right? So for example, it goes like this: 1 factorial, right? Which is equal to 1, right? And then we have 2 factorial, which is equal to 2 times 1, which is equal to 2, right? And then we also have 3 factorial, which is equal to 3 times 2 times 1, which is equal to 6. So those are just different ways. So it goes downwards, right? But we can't say 3 times 2 times 1 continuously. We can't, if they give us a number like 20. We have to say 20 times 90 times 80 times 70. That will take a long time. That's why we have the function factorial. So you can just say 20 factorial and put it in your calculator and you will get the result of how many available options there are. So now let's do an example to see what I'm talking about. So example 1, it says, okay, so my example 1 says example 1 phone. That's my word. That's what I want to arrange. It says how many different ways can you arrange the letters in the word phone, right? Every individual letter like P-H-O-N-E. How many different ways can I arrange those letters? Not all of them will make sense, but those are options. So how do I do it? I count how many letters I have, which is 1, 2, 3, 4, 5. So I have 5 letters. So I need to be able to arrange. How many times can I arrange those 5 letters in different ways? Maybe I might start with an H, or I might start with the O and have an H afterwards, or a P. So how do we do that? That's where factorial comes in. So we'll say, for me to find out how many options are available, I will say 5 factorial. So I'm saying 5 factorial. I'm saying there are 5 words. And if I say 5 factorial, it will find how many different options I can arrange those 5 words in. The letters would then, which is then equal to 120. So there are 120 different ways that I can arrange those letters in the word phone, right? So let's look at another example, right? This example is a little bit more tricky. Okay, so my example 2, right? My example 2 reads, in a class there are 4 girls and 3 boys. How many different ways can they sit if the boys are supposed to sit on one seat together, and the girl is supposed to sit on another seat together. There are two seats, and the boys are supposed to sit on one, the girls are supposed to. You might not have what so and so has, but be grateful for what you have. No matter how little, be grateful that you have it. Sit on another one, right? How many ways can they sit, right, on those two benches, right? So how do we find this, right? So let's write down. So there are two seats, right? There's two seats. The girls can sit on this seat, or they can sit on this seat, and the boys can also either sit on that seat or on that seat. So we want to see how many different arrangements that are possible, right? So let's look at the first one. The boys can sit in how many? The girls can sit in four different ways, right? So the boys can sit on 4 different ways. So that is 4 factorial, right? And the boys can sit in 3 different ways, in 3 factorial different ways, right? So that will be 3 factorial, right? So now we have 4 factorial and 3 factorial, right? But now the boys can either sit here or there, and the girls can either sit here or there. So we need to have 2 factorial because there are 2 options, right? Where the boys and the girls can sit, right? Because there are 2 seats. So we also have to say that there becomes 2 factorial, right? Because the boys can sit on one seat and then the girls can sit on the other one. Or the girls can sit on one seat and then the boys can sit on the other one. So the total factorial, right? The total options here would be 4 factorial. So we have 2 factorial multiplied by 4 factorial multiplied by 3 factorial. This will result in us giving us all the different ways the girls and the boys can sit. So this will give me. So my answer is 2, 8, 8. Those are the different number of ways that the girls and the boys can sit, right? So that is basically one of those. So now let's look at the option when there are repeats. If there are repeats, let's say we have a repeat of, let's say in a word, we have like a word like gang. We have a repeat of the word G. Let's see what happens. So over here, we're talking about if there are repeats, right? If there are repeats. So example 3 says, the word gang, right? Let's work with the word gang. So we want to find out how many different ways can I arrange those letters, right? How many different ways can I arrange those letters? So how do I do that? There's a repeat. What repeat is it? The G occurs twice. So how do I deal with that? How I deal with that is I say, since there are how many words there are there? There are 4 words. So 4, right? So there is 4 factorial options already, right? But since there's a repeat, we have to divide it by how many repeats there are of a specific letter. So since there's only one letter that's repeated, it will be just 2 factorial. If let's say the word G was repeated twice and the word A was repeated twice, it will be 4. It will be whatever total number of options factorial is divided by 2 factorial times 2 factorial because A is repeated twice too, right? So in instant, there's only 4 options, so it'll be 4 factorial divided by 2 factorial, right? Which is now equal to 12. So if your words repeated more than once, if you had another word in that repeated twice, let's say it was gang, and it was Ganga, yeah, let's say G-A-N-G, and then there was an A at the end, right? So how would you calculate that? You calculate that by saying there's 5 options, so it would be 5 factorial, right? 5 factorial divided by 2 factorial. The first 2 factorial is for the G's that repeat, and then times 2 factorial for the other letter that repeats, which is A. So it will be 5 factorial divided by 2 factorial times 2 factorial, because there are 2 different words that repeat twice, right? If it repeats 3 times, it will be 2 factorial times 3 factorial, right? So that's basically it when we have repeats in a sequence, right? Okay, now we want to speak about limited number of places, right? Let's say, for example, there can only be 3 winners, right? There's only 3 places for first place, second place, and third place. But there are 100 contestants. We want to see what is the probability of how many different ways or options. If you don't take risks, or risks, whatever, if you don't take risks, you'll never improve. You have to take your risk for you to be able to improve, for you to get to a better you. Are there for them to, for number 1, 2, and 3 to be arranged, right? So how do we do that? Let's look at that. So the formula that we use for this section 4, for this certain type of thing where there is limited number of places allowed, right? This is what formula we use. So this is our formula, right? It's n factorial in brackets n minus r factorial. What is the r? R is the limited number of places, right? N is the total number of options as usual, right? So n factorial, right? So let's do an example. Example 4. My example 4. Okay, so my question reads that there are 9 different numbers that you can choose to make a 4-digit code. How many numbers can the code be? How many different ways can the code be arranged? Or can say the 4-digit password, and how many different ways can the 4-digit password be arranged? Okay, so what does that mean? It means that let's bring the formula down first, right? Because we are going from 9 different choices and we have to fit that into 4 places. So now that shows that there's a limited number of places, right? So let's look at it like this. So let's write down the formula first. So our formula reads n factorial in brackets n minus r factorial, right? So let's replace what we know. How many different options could we have? It will be 9, right? So it will be 9 factorial divided by, in the bracket we still have, it's still 9. 9 minus what? 9 minus the limiting number. What's the limiting number? The limiting number is you can only have a 4-digit code. So the limiting number r is 4, right? Factorial outside, and that is basically it. So what you do from here, you just put in your calculator and the value that you should get is equal to 3024. So that's how many ways that 4-digit code can be arranged, right? So it can be arranged in 3024 different ways. That 4-digit code from 9 numbers, you can make 3024 different 4-digit codes. So yeah, that's basically it on probability. So yeah, that's it. These are your free marks. Go get your free marks. Do not forget to study this session here. It's very important, right? Do your revision, do your examples, and that's it. Boom, that's it.